This is A-level mathematics, 5.5, double angle formula. Alright, so double angle is actually just having the same angle twice. So, the addition formula for sine, okay, if I plug that in for A, okay, I rearrange it, I both get the same thing, and so it's going to be 2 sine A cosine A. Double angle for cosine, okay, I plug it in, rearrange it, I get cosine squared A minus sine squared A. Use Pythagorean identity, cosine squared plus sine squared is equal to 1. Rearrange that, I could substitute sine squared is equal to 1 minus cosine squared right here. Then plug it in, do some rearranging right here, and I should get 2 cosine A minus 1. So that's an identity, and then I do the same thing for my cosine value. So cosine squared is equal to 1 minus sine squared. Right here, do some rearranging, and I get 1 minus 2 sine squared A. That right there is going to be my third identity for the cosine double angle. Tangent double angle, 2 tan A minus, 1 minus tan squared A. So this identity, we normally don't do this very often, especially because you have to actually find the tangent first. We know the sine, we know the cosine, they're on my unit circle, but because of this, we have to have the tangent in the first place. So it's a lot more work, where we could have just did sine over cosine. So however we're going to do it, sine over cosine. So whichever identity you want to use for that instead of the tangent. Now, let's take a look at this next problem right here. Given cosine A equals 1/3, find cosine 2A. So cosine 2A, let me see, I could use whichever one I want, but because I'm given the cosine, I'm not going to use the sine. I'm not going to use this one right here because it has a sine. I'm going to use this one right here. So it's going to be cosine of 2A is equal to, right here, plugging that in, 2 cosine squared A minus 1. So we know that cosine A is equal to 1/3, so it's going to be 2 times 1/3 squared minus 1. It's 1/9. That makes it 2/9. So that's going to be 2/9 minus 1 is going to be 9/9, which gives me negative 7/9. So cosine of 2A is negative 7/9. Alright, half angle identities. So half angle, this one's actually not in the textbook. It's not in the book that's given. They expect you to actually go ahead and derive this from other angles. So instead, I find it a whole lot easier to just give you this instead of actually having to try and derive it yourself and get a formula for it. So half of this. So let's say I wanted to try and find the sine of 15. I know what the sine of 30 is. So the sine of 30, so I would do that. So sine of 30, so because 30 over 2 is 15. And if that's why I would use this one instead. So 30 over 15 would be 2. Then I'd be cosine of 30. Plug that in, do my math. Okay, come out with whatever I get there for that. For my half angle identities. So it's the same thing for all of them. It's just whatever is given to me or how I want to go about getting it. I could have used angle subtraction of 45 minus 30 to get 15, but anyway around it, I'm still going to come up with the same thing. Alright, 5.52, given that cosine A is equal to 1/3, we're going to find cosine of half A. So again, use that identity I just gave you. We're going to have cosine of, let's go with A over 2, half a means the same thing. They just write it like that. Equal to plus or minus 1 plus cosine A over 2. Okay, let's plug in our values. So cosine A is 1/3. So bring down equals plus or minus square root of, now replacing it, so 1 plus 1/3 over 2. So on top, I'm going to come up with, so that's 3/3 and that's 1/3, that's 4/3 over 2. Let's rewrite that. So dividing by 2 is the same as multiplying by 1/2, so I'm going to have 4 over 3 times 1 over 2. That means I'm going to end up with the plus or minus square root of 4 over 6. Now simplify my radical by separating it. So square root of 6 on the bottom and square root of 4 on top. Okay, separating my fractions, so I get plus or minus 2 over rad 6. Okay, rationalize, top and bottom, square root of 6 over square root of 6. So my answer is going to be 2 square root of 6 over 6. Don't forget my plus or minus. And then from right here, I could reduce the 2 over 6, so it's going to give me plus or minus square root of 6 over 3. That's my final answer. So I do have two possible answers on this one. It just depends on where the angle is going to be located at. Usually they'll say, oh, cosine has to be in the first quadrant. So we know in the first quadrant that cosine would be positive, and so I would just throw out the negative on this one. But it doesn't really say where it's located at, so there's a possibility for it to be positive or negative. Alright, let's take a look at 5.5.3. We're going to solve for angle theta. Theta is going to be between 0 and 360, so that means it's going to be in degrees. Okay, let's start by factoring this thing. So I'm going to move this over here and set it equal 0, so I'm going to get 2 sine 2 theta minus sine theta equals 0. Now I have a double angle and a single angle, so I need to try and get rid of this double angle so I could have all single angles here, because I can't work it out until I actually have all of the same thing. So I'm going to use the identity for the double angle to replace for that sine 2 theta. Let me see, it's going to be 2 times the double angle for sine 2 theta is 2 sine theta cosine theta minus sine theta equals 0. Right here I'm going to end up with 4 sine theta cosine theta minus sine theta equals 0. Now they both have a common factor of sine, so I'm going to have sine theta, and I'm going to have 4 cosine theta minus 1 equals 0. So right here, my sine theta is going to equal 0. And over here, I get 4 cosine theta minus 1 equals 0. So set each part equal to 0 using zero product rule. Anything times 0 is 0, so that would make that true. So now set each part. So right here, let's start by adding 1 divided by 4. So cosine of theta is equal to 1/4, where sine is equal to 0. So on this one right here, I don't have anything on my unit circle where it comes up to this. So I'm going to go ahead and actually have to figure this one out in the calculator. So let's take a look at the unit circle first to figure out where is sine in between 0 and 360, where is sine equal to 0. So here's my unit circle. Sine is going to be equal to 0 right here at 0, 2 pi, and pi. So which ones am I allowed to use? Okay, here I am using 0. I could use both of those. My answers here are going to be 0, 180, and 360. Because I can include 0, and I can include 360. So therefore, I'm going to have 3 answers off that one. Now, for right here, for the cosine value, I'm going to have to use the inverse identity on my calculator. So using inverse identity on the calculator, so make sure it's in degree. I'm in degree here. So second cosine. So inverse identity would be look like this. Cosine inverse 1/4 is equal to theta. So that's going to be 1 divided by 4. Close that. It's going to be 75.5. So we're going to have 75.5. These are all in degrees also. So 75.5 degrees there, but because on my unit circle that the cosine is allowed to be positive. Okay, cosine is positive in quadrant 1 and in quadrant 4. So the way I would do this one, I would go 360, because it would go down this way, minus the 75.5. So for my second one, it would be 360 minus 75.5. And I should get my other angle at 284.5 degrees. So my solution set, 0, 75.5. Next one's 180. 284.5 and 360 as my answers. Alright, the homework assignment for this, page 75, 1 through 10 all, 1, 3, 5, 7, 10. So 10 all. So all for all those problems there.